Hello, welcome to Ganitha Vahini. I am HarshaVardhana. In a previous session, we saw properties of a conjugate and a modulus of a complex number, and we also done some of the problems of conjugate and modulus of a complex number. In this session also, we are going to solve some more problems on the complex number, that is, find the conjugate and modulus of a complex number 3 minus 2i into 3 plus 2i into 1 plus I. For this problem, we have to do in step by step method. First, we multiply the complex numbers. That is 3 minus 2i into 3 plus 2i, that is 3 square minus 9i square, that is equal to 9, minus 4i square, that is equal to 9, minus 4 into minus 1, that is equal to 13. After this, we multiplied by the third complex number, that is z. Z is equal to 13 into 1 plus I, that is equal to 13 plus 13i. The resulting complex number is z, that is equal to 13 plus 13i. In second stage, we have to find the conjugate of a complex number. If z is equal to a plus bi and z bar is a minus bi, this is the conjugate of a complex number. For z is equal to 13 plus 13i, the conjugate is z bar, that is equal to 13 minus 13i. In step 3, we find the modulus of a complex number. We find the modulus of a complex number by the formula mod z is equal to root of a square plus b square. Therefore, if z is equal to 13 plus 13i, mod z is equal to root of 13 square plus 13 square, that is equal to root of 169 plus 169, that is equal to root of 338, that is equal to 13 root 2. Therefore, the answer is the conjugate of a resultant complex number is 13 minus 13i and the modulus is 13 root 2. After this, we move to the geometrical and polar representation of a complex number. A complex number can be represented geometrically as a point x, y on the Argand plane, or in the polar form as a pair r, theta, where r is the origin, that is modulus, and theta is the angle from the positive real axis, that is argument. The relationship between the two is given by x is equal to r cos theta and y is equal to r sin theta, leading to the polar form z is equal to r into cos theta plus I sin theta. Then after this, we have to know about the Argand plane. Argand plane is a 2D graph for the complex numbers where the horizontal axis is real and the vertical axis is imaginary. Means Argand plane is a coordinate plane used to represent the complex number graphically. And in Argand plane we have two axes, that is horizontal axis is the real axis and the vertical axis is the imaginary axis. After this, we have representation. A complex number x plus y is plotted as the point x and y on this plane. See the diagram. Here it is a diagram of an Argand plane which shows point x and y. In the above representation, the complex number length of the line segment OP is equal to modulus of the complex number, and theta is the angle formed by OP in the anti-clockwise direction with the positive direction of the x-axis, and is known as amplitude or argument of the complex number, denoted by amp z or argument z. From the above figure, theta can be calculated as follows. Usually we take it as tan theta. Tan theta is equal to y by x. That implies tan theta is equal to imaginary z over real z. Therefore, theta is equal to tan inverse of mod of imaginary z over real z mod. After this, we have polar representation. Polar representation is the alternative way to represent a complex number using the magnitude and direction. Its modulus r is the distance of the point from the origin. It is calculated as r is equal to root of x square plus y square. And the argument theta, the angle measured counterclockwise from the positive real axis to the line connecting the origin to the point. And then after that, to represent the polar representation, the polar form is z is equal to r cos theta plus I sin theta. After this, we have to know about the relationship between the two. From first, we have to convert from Cartesian to polar. We can find the polar coordinates r comma theta from the Cartesian coordinates x comma y using these formulas. R is equal to root of x square plus y square, and theta is equal to tan inverse of y by x. From polar to Cartesian, you have to convert back from polar to Cartesian using the relationship x is equal to r cos theta and y is equal to r sin theta. With this, I will conclude this session. After this, if you have any doubts or need clarification regarding to the video or this chapter, please feel free to reach out. For those who enjoyed the video, consider subscribing to the channel, and if you have not watched the video, I will include the link in the description box. Please check it.